Assalamualaikum dan selamat sejahtera. We go to 7.1 acid and base for part 3, which is salt hydrolysis. Actually, the salt will classify into 3 types, which are acidic salt, basic salt, or neutral salt. For further details, look at example 1. Determine either NaCl is acidic or basic salt. If the question asks you to determine the acidity of the salt, or the question asks you about the pH of the salt, that means we just refer to the subtopic salt hydrolysis. Okay. First step, you only refer dissociation of the salt. First, you must dissociate the salt in water. How you want to dissociate? Okay, NaCl is a salt that dissolve in water. So when it dissociate in water, you must use the single arrow, because this is the salt that 100% dissociate in water or soluble in water. So produce its ion, which is sodium ion and chloride ion. All the phase for ion is aqueous. Okay, you have to put H2O here. That means you needed a water to dissolve this salt. Okay, then you must check all cation is come from a base. Okay, so you pilih base yang suitable menghasilkan Na+. So I take base yang sesuai untuk menghasilkan Na+ adalah sodium hydroxide. Okay, kenapa saya pilih NaOH? Okay, why I choose NaOH? Because macam saya kata, when I dissociate NaOH, saya menghasilkan ion Na+. This. Okay, so we check to another part, which is an ion, chloride ion. All the anion is come from an acid. Okay, so you have to create one acid that produce Cl-. So I choose HCl. Why I choose HCl is the suitable acid to produce Cl-, because when I dissociate HCl, I produce H+ and Cl-. So since it produces Cl-, it's suitable, similar with this ion. So after you choose a suitable base and suitable acid that produce both cation and anions, you have to classify either, okay, this base is weak or strong base. Sodium hydroxide is metal hydroxide, so it is strong base. Okay, you classify also for HCl acid here is strong or weak acid. Okay, HCl is hydrohalic acid, that strong acid. Okay, after you get this is strong base and strong acid, baru you akan buat jawapan dalam statement. you ambil yang original, this ion, okay, you akan clarify. Na plus cannot ionize in water. Also, this anion, Cl minus, cannot ionize in water. Okay, so kenapa saya sebut cannot here? Because both acid and both base is strong acid or strong base. So kalau strong, kita akan tulis cannot ionize. Bila cannot ionize, okay, that means dia tak menghasilkan OH ataupun H+. So, kenapa cannot ionize in water? Because dia terlalu strong. So, tak memerlukan medium water lah. Okay, untuk menunjukkan sifat acidity ataupun base. So, as conclusion, so that bila both cation and an ion is cannot ionize, so that NaCl salt is neutral salt. Okay, kalau both adalah cannot, so they are neutral salt. Neutral salt which is with pH equals to 7. So you just write this statement, and this statement to answer for this question. Okay, look at question number 2. Okay, determine sodium ethanoate is acidic or basic salt. First of all, you have to dissociate your salt. CH3 COONA, phase all the time is solid. Okay, dissociate in water to produce its ion CH3 COO minus and Na plus. All the ion is in aqueous phase. Right? So all the cation is from base. Okay, so cari base apa yang sesuai di sini. Sorry, this is an ion. Okay, this is an ion. Is always from acid. So cari acid apa yang sesuai di sini. Okay, katakanlah ini you hanya accept the proton saja. Okay, CH3 COOH. Why I choose this acid? Because you conteng di tepi ni CH3 COOH. When I dissociate its acid, this acid, I will get this ion and H+. So similar that I want this ion. So this is suitable acid. Okay, so all this cation from base. Okay, cari base apa yang sesuai untuk hasilkan Na+. Saya ambil NaOH. Why I choose the NaOH? Because when I dissociate NaOH, I will get Na plus and OH minus. Okay, this is cation that I want. After you choose the suitable acid and base, so you have to classify the strength of acid and base. Okay, CH3COH is organic acid. All the organic acid is a weak acid. Weak acid. This is metal hydroxide. All the metal hydroxide is strong base. So, when you get strong base, you have to conclude here. That means you conclude yang ni. Okay. Na+ cannot ionize in water. Alright. Cannot because it said this strong. Okay, how about this? Weak. Kalau weak, that means you conclude this anion. CH3COO minus can ionize in water. Okay, since you said can ionize, you have to prove by the equation. What the equation involve? Okay, you write again CH3COO minus. Can ionize, that means react with water. Okay, can ionize, that means react with water. Okay, all the ion is phase aqueous. H2O remain as liquid. So when it ionize, make sure you use a reversible arrow here. Okay, so kalau lah di sini, apa the produk nak jadi kat sini? Okay, kita tahu dia adalah, okay, dia datangnya daripada asid. So, kalau lah ini asid, okay, weak acid sini. Kalau lah ini adalah asid, partnernya bernama conjugate base. Betul tak? Kalau di sini asid, partnernya adalah conjugate base. So di sini akan bersifat base, iaitu conjugate base. Base, that means accept proton. So kat ini akan jadi, kalau sini conjugate base, base maksudnya bersifat base. Base adalah proton acceptor. Abaikan perkataan conjugate. Conjugate itu adalah pairing sahaja, tetapi dia masih bersifat base. So dia akan accept the proton will become CH3COOH. Kalau ini proton acceptor, H2O ini akan jadi proton donor. So become OH minus. So semua phase ini adalah aqueous. Alright? Okay. Di sini kita patah balik daripada aspek definition acid and base. Okay? Okay, from this equation, you nampak dia ada menghasilkan OH minus. Bila dia menghasilkan OH minus, itulah tandanya, okay, thus, okay, since it produce OH minus here, so that CH3COONA, garam itu, is basic salt with pH greater than 7. This is your answer. Okay, since kamu nampak dia menghasilkan OH minus dalam equation ini, dalam ionize kamu, so terus tentukan garam yang diberi dalam soalan itu adalah basic sebab menghasilkan OH minus. So kalau dia adalah basic, terus kita tentukan pH-nya greater than 7. Kita tak boleh tentukan dia punya pH secara specific value. Kita hanya anggarkan pH-nya sama ada less than 7, equal to 7, or greater than 7. Okay?